Thanks, Justin. Thanks, everyone. Yeah, super happy to be here and just trying to share a little bit of the work that we're doing back home, and kind of like my slide says here actually at the bottom is my whole aim, and the aim of Continuum Ag is to be a catalyst in regenerative agriculture, and I think that's the whole purpose of being here, is to be a catalyst between the farmers and folks that we have sitting in this room and the farmers and folks that I work with clear across the country. And we'll show you a little bit more about them, a little bit about what we're working on here, and be able to spark some interest, and like Justin said, show a little bit of some of the resources I think that can really help you guys. I think fits well into Graham's presentations today and tomorrow. And then tomorrow we'll get into more of where I think this is all going. So my purpose here is a couple different things. So number one, we want to learn how to document and improve soil health. And that's the whole quantifying soil health, and that you can't manage what you can't measure. We now have the tools to be able to measure that, and they can be utilized here too. We've been utilizing them here for a couple of years already. We know that they can work. Tomorrow then I'm going to get into why this is going to be a key in the future, even beyond what it is right now. And like Justin said, for the farmers that I work with back home, our soils are amazing to begin with, so we've gotten lazy, and we haven't had to focus on micronutrients. We haven't had to focus on biology because we had it given to us for free. Well, now that's catching up with us. Now we have issues going on, and we have to get a focus back into our soils more in depth, like you guys have to here, just in order to survive. So we have a lot that we can learn from you folks as well in order to keep improving our soils. But we do start with pretty good stuff. The picture there is what we're dealing with back at home after a couple years of cover crops. I'll show you a little bit about that. About me. Went to Iowa State and grew up on the family farm. We'll show you some of that. Now started Continuum Ag about 3 years ago. Basically, we do soil health consulting, and then I have another company as well called Senior Management that does third-party data analysis and data reporting for farmers and land managers and eventually food companies all over the world. All right, so a little bit about where I'm from. So quite the trip to come all the way down here to Cape Town, or down here to South Africa, but awesome to be back here down for the second time in about a year and a half. But from clear up here, kind of central United States. And this is a little bit of a representation. Sorry with the blown up size here, we're losing some quality, but this is showing the size of South Africa compared to the United States. And I'm from here in Iowa in the middle. So relatively average size state for back around home. And that whole area is basically all corn and soybean production, which I'll show you. This is a picture of Iowa and essentially the makeup of Iowa. And those in the back probably can't see the graph down here in the corner. Yellow is corn, green is soybeans. That's about it. That's what we have. You drive through Iowa and it's cornfield, 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 soybean, soybean, soybean. That's it. But for those of us who like corn and soybeans, that's a great sight. But for you guys down here that have all the diversity and all the different things going on, you guys will get bored pretty quick. Down in the lower part of the state, especially, kind of up here in the northeast as well, this river that runs along the side right here is the Mississippi River. On the left side of the state is the Missouri River, which eventually leads into the Mississippi. But along those sides, there's some pretty hilly areas as well, where there's a lot of pasture, there's a lot of hogs, or a lot of cattle in those areas. Iowa's number one state in the U.S. for corn, soybeans, hogs, poultry, wind energy, ethanol, and basically this map shows kind of why it's all corn and soybeans. But that's also part of what's given us issues now, is we have two crops. And some people it's one crop, one crop, one crop, same thing over and over and over, and that gives us issues. Now, the big driving force back home for soil health and conservation and whatnot is the other color that you see on this map besides the corn and soybeans, and that's the water. This is the Mississippi River that is right there, right alongside most of the water leaving Iowa. It's all going to end up in this river at some point, and it's causing us a lot of issues with dead zones, with the hypoxia issues that we have down in the Gulf of Mexico now because of all the nitrogen and phosphorus that we're losing down to the Gulf of Mexico, causing a lot of issues. I just spoke 2 weeks ago with a guy from Louisiana. He was a shrimp farmer from down there, talking about the issues that they're having, and it all stems from upstream. So this river is a big driving force for us on why we have to do things better, why we have to be more efficient, why we have to make sure that we keep our nutrients in the soil and not lose them down the river. So just a little bit, I guess, on corn and soybean kind of production. Small area, essentially, compared to South Africa, but it's huge production. And according to, so I wanted to get a little bit of show of hands here. Farmers in Iowa are being pushed by big ag companies, and have for the last 40 years or so at least, that we have to feed the world. We have to feed the world. We have to feed the world. That it's basically Iowa farmer sole responsibility to feed the world. Is there anyone in this room that thinks that is accurate? Didn't think so. And if I was back at home and I said, how many of you think here that it's your responsibility to feed the world? 9.5 billion people, we have to feed more people, we have to raise more, we need more fertilizer to do it, we need advanced genetics to be able to do it, we need bigger equipment, more land, maximize production. Those guys would raise their hands because they think that it's their job to feed the world. But you guys are all producing more too, and it's not necessarily about quantity all the time. It's about producing things with better quality, and we're going to get into that. A little bit about what we're doing on my home farm. I farm with my dad. We've been farming in this area for well over 100 years. My family has, after immigrating from Europe, and settled in this area. And we have some of the farms that we farm that my family bought it from the guy who bought it from the government back in the 1800s. So kind of cool. But on our farm, we've been experimenting a lot with cover crops. This picture shows us drilling soybeans directly into cover crop here this spring. This would have been end of April. This year is when we're planting, and then we'll harvest in October. And so we've got a strip trial kind of system set up here. The grain bins right there at home to be able to store everything. And not a huge operation by any means. We farm less than 1,000 acres, so that'd be maybe 400 hectares or so is our operation. Just a small family farm. Here's a couple pictures of the cover crop work that we've been doing back around home, trying to get a little bit of diversity going, but it's mostly all just cereal rye cover crops. A couple pictures on the right. On the bottom, we're planting soybeans directly into growing cover crop, and on the top one, we're planting corn directly into green growing cover crop there as well. And it works pretty slick. We've been using it for a couple of years now, no-till for a long time, trying to do things better, trying to improve, and now we'll get into how we're quantifying some of those improvements. I didn't raise my hand when you asked how many people have earthworms. We have a couple. We could use a lot more, but we do have some, and that's what you see there in the bottom left. So for me, soil health, just like Graham is saying too, when I talk about soil health, I just talk about balance in the soil. Balance between the chemical, physical, biological portions of the soil, balance in calcium, magnesium, fungal to bacteria, carbon and nitrogen, all of those kind of things. We have to have balance in our soils. And I think the whole takeaway here, although our farming practices and yours are a lot different, the principles remain the same, that we just have to create balance in what is that soil supposed to be able to do, how do we improve it strategically over time in a system that's balanced, not just throwing out NPK and lime like we've been doing back home for years and throwing things out of whack. We have to do things in balance. Now we've got the tools to be able to do that. My approach is a little bit different too than how agriculture has been viewed in the U.S. for a long time. We've been viewing everything as the same. Every cornfield the same as the next, every corn plant the same as the next, and viewing the soil as a mathematical equation, a linear regression, and it's not. We've been viewing it as a dead growing medium for just growing at the maximum production that we can and taking off as much production as we can because we've been preached to that we have to feed the world. We've got to raise more. And it's not that case. We view the soil as a dynamic continuum going all the way down to the molecular and the microscopic level. And that's where it's been really interesting here, that you guys have been working on that for a long time. You have to be down at the molecular and microscopic level, and now we're able to really do that with boots on the ground, agriculture, and the testing that we're doing. So I think, though, before we can have sustainable agriculture, we have to have a regenerative agriculture, and that's what Graham talks a lot about too, and what we're pushing back home is what we're doing right now is not sustainable. We have to improve. We have to improve our soils and regenerate the system before we can be sustainable, and we have the data now to be able to show us how to do that. Soil health has become a necessity, and it's been a necessity for you guys, but now for us back home, it is as well. What we're doing is not working out. We have to do better. Here's a tool of how we're able to do that. The Haney Soil Health Test has really helped us a lot to look deeper into our soils, to look at micronutrient balances, to look at the basics of biology in the soil and the food that biology is trying to eat. The Haney Soil Health Test here, developed by a soil scientist back home. He's down in Texas, called Dr. Rick Haney is his name. I've been working very closely with him. I actually send soil samples weekly to Dr. Haney's lab. The current soil sampling practice, and has been for a long time, is to use grid soil samples and sample your farm once every 4 years. In some of my research projects, we're pulling soil samples 40 times this year, way more than what's ever really been done before. A couple differences here on why this test is important and why I think it can help you guys as well. The extraction that Dr. Haney developed is called a H3A extraction. It's a weak acid extraction that's representative of what the plant is actually seeing. So the plant exudates, the sugars, the compounds that go down into the soil have a pH that's similar to this extraction that Dr. Haney is using. In the rhizosphere there around the roots, when you pull out a root, you can feel kind of the oily substance on that root. That's where all the bulk of the microbes are living, and where the nutrient interactions are happening, where the plant to soil or plant to microbe to soil interactions are happening. Now we have a test to identify what's going on in that system as a snapshot in time. We're looking at things like nitrate, ammonium, this clicker maybe you can see, nitrate, ammonium, and then those added together is our total inorganic nitrogen. We're looking at organic phosphorus and inorganic phosphorus. We're looking at potassium, calcium, magnesium, sodium, sulfur, boron, iron, manganese, copper, zinc, and some other ones as well. We're also looking at organic carbon, which is the food for the microbes. That's the simple sugars that they want to eat. And we're looking at organic nitrogen, which they utilize to produce the enzymes to eat the carbon. And then we're looking at our overall biological activity too, with a CO2 burst. So microbes breathe off CO2 just like we do. So if we were collecting the CO2 in this room, as the day progresses, we're breathing out CO2. The CO2 concentration in this room increases. So the more people there are in here, the higher that CO2 would go up. Same thing would happen if there was even less of us, but we were all running around in here and being active and breathing a lot and releasing CO2, the CO2 would go up in the same manner. This CO2 test is essentially that same thing. The more microbes we have in the soil, they're going to release CO2. Also, the more active microbes we have in the soil, they're going to be releasing CO2, and now we can measure that, get a good idea at least on, hey, we're improving the system, we're moving in the right direction. That's really what quantifying is all about with a test like this. So just showing that we're able to make improvements over time. I think where this can really help is to give a good overview snapshot of where are you at right now. Let's deploy some practices to help us to do better, and you just monitor over time to show, hey, I'm moving in the right direction, I'm doing things better, okay, I'm solving issue number 1, let's move on to issue number 2, number 3, number 4, and so on. And by learning together, you can really get good at knocking issues out as quickly as we can. So that's the Haney Soil Health Test. That's the report that Brookside gives. I'm modifying the report a little bit to dial it in, and we're calibrating the report essentially to be able to show how do you compare to other relative soils. I think that's really important. So that's how I take the data and form it a little bit differently so it's more representative of what you guys are actually looking at. This is another test I wanted to talk a little, just kind of briefly about. I think it fits well into Graham's message too. about the human biome. This is a lab out of California, a Silicon Valley company called Trace Genomics, and they do a soil biome test. So they take soil DNA, and we can look at 200 individual species of microbes. Super cool. What we see on the top there is nitrogen, phosphorus, potassium, carbon. That range, and this is just a small snapshot of their report. They give a very thorough report. This is a little snapshot of it. At the top, this is our ability to cycle those nutrients, which is literally being sustainable. Is if your soil can cycle nutrients on their own, that would be excellent. So that's what we're looking at, trying to manage that, trying to improve those parameters, because they understand the microbes in the soil that are helping us to convert nutrients. Now we're actually putting some data behind it and showing how do we improve our soil's ability to cycle nutrients. At the bottom is just a little snapshot that they also identified the individual species out there in the farm. This says Phytophthora, Fusarium, Pythium, Anthracnose. Just a couple of the issues that we deal with in corn, but you can dial those in to whichever species are most pertinent to your operation. They can report those back. So super cool. But now basically the whole point being we now have the ability to really dial in, give us a more thorough look at our soils like we never have been able to before. And now we can monitor improvements over time. We can be most efficient in deploying management practices, most efficient in where you want to put your money first, because making this journey, especially in the transition, I think at the beginning, there can be some expenditures to it, but by being the most efficient, we can really make things happen quickly, and that's helped us out a lot. Wanted to hit on what's to come with this whole area. Soil sensors, real-time data is where this is all going. We need to be able to prepare ourselves for that. A lot of these sensors are a couple of years out or so, 18 to 24 months at least for a lot of them. There's some that are available right now in their basic forms, but there's some sensors coming that are really going to change the game, give us real-time information, looking at things like temperature, moisture, pH, salinity, nitrate. There's ones for phosphorus and potassium that are being developed right now, CO2, O2, be able to monitor these things in real time. Some of these sensors would stay out there in the ground and monitor data all the time based on weather, based on your input, based on your management, and monitor changes in data continuously. And other sensors are on the equipment to be able to monitor as you're going across the farm and make real-time application decisions. Precision Planting, which is owned by John Deere, already has that for corn planters. So they can monitor organic matter, moisture, temperature, pH on the fly. As you're planting, now you can adjust your planting rate based on organic matter in real time. So super interesting on what's to come. The other piece, and this picture is from Dr. Haney's lab. I went and visited him in January. He has real-time CO2 sensors here using infrared to monitor CO2. The CO2 sensor that he has in his lab, we have handheld, same type of device, but a handheld version that you can do at home, monitor biological activity in real time. Those sensors are extremely cheap, not commercially available for sale yet, but they're working on it to be able to help us to monitor where's our biological activity at. You can do it right at home instead of having to send a sample a long way away. So there's some interesting tools coming, but for right now, we've chosen to use the soil health testing from certified labs like Brookside to be able to give us good data, and it still works very economically for our situation. So we've been doing a lot of trials and stuff, looking at side-by-side things like cover crop versus no cover crop, one management practice versus another, tillage versus no-till, one stabilizer versus another, or versus unstabilized nutrients, one biological product versus no biological product, whatever is interesting for your operation. I think it's awesome to be able to go implement a small trial, test it out, see what happens. You don't have to do it on tons of hectares for you guys, acres back home. You don't have to do it on a huge area. try stuff, figure out what's going to work for your operation. There's a ton of tools that we can use now to monitor and make sure that what we're doing is helping us to get a good return on investment. Some of this data now, we've been looking all over the winter. So if you guys have a winter like this, I think it's awesome outside. This is our winter back home. We're pulling soil samples in the snow is what this is here. And our ground is frozen, and you can't necessarily put a soil probe through the ground when it's frozen, so that's what little brothers are for. And I sent him out here with a cordless drill and coveralls, and he goes out here and he gets soil samples in the snow, and I sit in my office and just wait for the data to come back, and then I pick through it. Just kidding, I go out there too and pull samples, but interesting things happen now with the data tools that we have to monitor items, monitor changes, monitor biology, monitor more in-depth parameters like we've never been able to before. Has been really awesome. There's only better things coming. And what we've learned is we can make improvements. We can see things quickly, and back home we're seeing improvements, and we're starting at a pretty good spot. We've done some testing down here, and you guys can see massive improvements so quickly because it's the law of diminishing returns. So for you guys, you have a ton to gain in biology. You have a ton to gain in yield and in productivity and in profitability, where back home we have to really pick through how are we going to improve, what products are we going to utilize. We're getting tons of stuff thrown at us all the time. You guys can be extremely strategic and really see improvements very quickly. But what's interesting is the things that we're learning back home, if we can see some little bit of improvement, you guys can see a lot of improvement. And things that you guys do down here, if you can see a lot of improvement, maybe we can see a little bit of improvement too and work off of each other in that matter. Little snippets here on some of the data that we've been collecting. This is monthly soil health samples looking at nitrate in the soil. And this is a cover crop trial that we've been doing now for 3 years. This is second year data, so from last growing season. And so this would have been the winter of 2016, or this would have been like growing season 2016 through the winter 2016 into spring of 2017. Side-by-side trial, and we're pulling samples on the 15th of every month in just a no-till system versus a cover crop system. And we've seen huge improvements to be made with cover crops for our system by building organic carbon, building biological activity, making nutrients more available. I've got a guy who's made phosphorus and potassium over 200% more available in about 18 months. Pretty amazing stuff with diverse cover crops and letting that stuff really grow, letting the biology do what it's supposed to do. What this graph shows is we planted over here in April. This is corn. Planted in April through June. We had a lot of nutrients that come available. Our soils are warming up. We've got mineralization. We have the fertility that's there and available for our corn crop. And then through June, July, August, our corn is utilizing nitrogen. We tassel at the 1st of July. This year is actually early, by June 26th. We tassel. And then through August, we're getting into, end of August would be where we're black layering. And then middle of September, we were harvesting. It was a little bit early corn. We usually plant 109 to 113 day maturity corn. And we harvested in the middle of September, and we had super high biological activity. Those microbes had fresh corn residue coming back to the soil. They had excellent weather conditions. And then in October, we had this huge flux of nitrogen come available. Right at the wrong time, right when we don't need it. Luckily, as this red line shows, we planted our cover crop at the end of September. And as that cover crop got growing into November, we were holding the nitrogen pretty consistently throughout the entire winter. With the blue line next to it, from October to November, the rain turned back on. We lost a little bit of that nitrogen to deeper into the soil. And over the winter, we were mineralizing. We were getting above freezing temperatures. Most of the time over the winter, the ground's frozen. There's not a whole lot going on for us. But this winter was a little bit different, where we had it would get above freezing and get below freezing, which it does every year. And we were mineralizing nutrients. They were coming available so that on February 15th, I had an extra 30 pounds of nitrate nitrogen available in the top 6 inches of the soil. Then in March and April, we got the spring rains that we get back home, and we washed away a lot of that nitrogen. It was completely gone. Nothing was applied during this whole time span because we were going to soybeans the next year. We didn't need any nitrogen to be applied, of course, ahead of our soybeans. All of that nitrogen that we had that was essentially left over after the corn crop, we lost all of it down into the river, essentially, or working its way down into the river. Harvest, high biological activity, lots of nitrogen release. We had mineralization. We lost it all, but luckily our cover crop, we were holding it. Now, one of my biggest aims with our studies on cover crops is we know we're holding nutrients. We know that that cover crop, of course, is holding nutrients. It's sequestering nutrients out of the soil. When do we get it back? So now I've been doing work with Dr. Haney to try to figure that out. And so when I started taking soil samples a couple of years ago, I was doing it on a month-by-month basis, which was a lot at that time, a lot more than what we've been doing. Then I was like, well, hey, let's see what happens twice a month. And then I'm like, well, let's do it once a month or once a week instead. So now I've been pulling soil samples once a week, which is a lot of work, but that's all right. We're learning a heck of a lot. Essentially learning that we are tying up nutrients, we're tying up nitrogen. This is total nitrogen again from the Haney test. Right when we're terminating our cover crop, we're getting a release. So the blue line is cover crop, where we're holding nutrients over the winter and we're releasing them back right at the right time, helping to utilize the cover crop as our nutrient stabilizer. We're also getting the biological improvement. We're seeing structure improvement. We're building water infiltration, all the other benefits of cover crops as well. Just trying to dial this in to help make the economics really work for us, and it can for you guys too. With this system. So been interesting there to see what we can hold, what we can keep in our system, or what we can help to recycle. And now we've got the data to be able to help us do that. So some applications, kind of some takeaways for you guys here today. In my presentation tomorrow, we'll get into the really exciting applications of this soil test. But for right now, it just gives you a better opportunity to be able to see where is your system at. Where's my micronutrients at? Where's my biology at? Where's my food for my microbes? How do I want to strategically go about leaving this conference here today? I think we've got the right tools to be able to do that. Testing before planting is kind of ideal. So for us, and you guys in the spring, it's a great time to be able to take that test and deploy what you're learning throughout the growing season. What we like to do a lot is take a zone sample and then split the application. So do what you're planning on doing versus a one variable change. Just try something new, see what happens. You can evaluate where your data was at, where your starting point is, change something up, and then see what happens. See which one you like better. Maybe what you're doing already is fine, but maybe this one variable change is what you're going to be doing going forward. And then if you want, you can come back in the season and monitor those too, or utilize the drones, utilize a lot of other technology to be able to monitor the impact in the season. So overall, I guess we know we have to do better. We know we have to do better as global agriculturalists, and we've got the tools to be able to do that. Like I said, tomorrow we'll get into really the exciting things on where this is going, what's driving this even beyond water quality, beyond soil health, beyond short-term gains and long-term soil health promises, into what the consumer wants, into the ties between soil health, human health, environmental health. Those are everything that's coming. The whole aim is we have to be improving now. We have to improve our soils in order to improve crop quality and in order to set yourselves apart from your peers and those who are not in this room today. And we'd love to help to be a piece of that. And I think this is a great group of folks in this room to work together and to help strategically improve our operations and agriculture around the world. So that's all I got for right now. We'll hand her back over.